welcome to grade 7 mathematics class. Today we are going to talk about the 25th unit, solids. Now quickly take out your mathematics textbooks and turn to page 123. Before moving to the lesson, I thought of telling you what you are going to learn after studying this lesson. So, by studying this lesson, you will be able to prepare models of a square pyramid and a triangular prism, draw the net of a square pyramid and a triangular prism on a square ruled paper, and know Euler's relationship for the above solids by considering the number of edges, vertices and faces of these solids. Right, as I have mentioned you before, today we are going to talk about solids. So, have you seen solids in your day-to-day life? I am going to present you some solids. Check whether you have seen these solids before. Here I have a die, a brick, a pot and a wood log. Those objects can be considered as solids. You may have gone through so many solids in your day-to-day life. So, what is a solid? Shall we define the solid? As you have learnt in science, solids should have a certain shape and it should occupy a certain amount of space. So, we can define a solid as object which has a specific shape and which occupies a certain amount of space is called a solid. Now, in a solid, there are two types of surfaces. First one is the plane surface and the second one is a curved surface. As you have seen in the previous slide, in a wooden log you can observe curved surfaces, in a die you can observe plane surfaces. Solid consists of faces, edges and vertices. Right. First of all, we will move on to the things we have learnt in previous grade. What we have learnt in grade 6? We have talked about three types of solids in grade 6. First one is cube, and we have discussed on the features of cubes. It has 6 faces. As you can see, a solid has 6 faces, 12 edges and 8 vertices. What can you say about the shape of a face of this solid? Here it is a square shaped, isn't that so? And all the edges are straight edges. Then we have learnt on the net of a cube. As you can see in the screen, in figure 2, I have mentioned a net of a cube. I am sure you have used it to make cube at school. But is that the only net that we can use to make a cube? No, we have 11 nets to make a cube. You have studied it grade 6 as well. Next we have learnt on cuboid. Here, there also we have discussed on features of a cuboid. It has 6 faces, 12 edges and 8 vertices. What can you say about the shape of a face of a cuboid? It is a rectangular shaped face and all the edges are straight edges. Then we have discussed on the net of a cuboid. In figure 2, I have presented the net of a cuboid that you have used to make a cuboid in grade 6. Next we will move on to the regular tetrahedron. In a regular tetrahedron, once again we have discussed on the features. It has 4 faces, 6 edges and 4 vertices. What can you say about the shape of a face of a regular tetrahedron? It is a triangle, isn't that so? So, we have 4 equal triangles in a regular tetrahedron. We will quickly move on to the net of the regular tetrahedron. In figure 1, I have mentioned the net that you have used to make the regular tetrahedron. Right. Now we will summarize the things that we have learnt in grade 6. When we consider about a cube, there are 6 faces, 12 edges and 8 vertices. When we consider about a cuboid, we have 6 faces, 12 edges and 8 vertices. When we talk about the regular tetrahedron, we have 4 faces, 6 edges and 4 vertices. Right, now it's time for you to do the review exercise. I'm sure you have done it already because you are ready for the lesson beforehand. Therefore, we'll quickly move on to the grade 7 solid lesson. This year, first of all, we have to learn about pyramids. Now, as you can see in the screen, there are world famous pyramids you all know. What are these? These are from Egypt. Thousands of years ago, Egyptians have made these pyramids, and that is the exact shape of the solid that we are going to learn today. That is a square pyramid. Square pyramid is a solid object consists of a square base and 4 equal triangular faces, and here I have taken a square pyramid to show you. Here we have 4 equal triangular faces, and can you see the base is a square. Now we will consider about the features of this square pyramid. We will see how many faces are there. Shall we count? 1, 2, 3, 4, and with the base you have 5 faces. 4 are equal triangles and 1 is a square face. And what about the edges? Shall we count? 1, 2, 3, 4, 5, 6, 7 and 8. We have 8 edges and all are straight edges. Then let's count the number of vertices. 1, 2, 3, 4, 5. We have 5 vertices. Now I am going to consider about the net of a square pyramid. Here, as you can see in the figure, you have to have a square and 4 equal triangles. So this is the net of a square pyramid. But when you want to make a square pyramid, you need to have the pasting allowances. Therefore, I have mentioned the net with the pasting allowances. But when we ask you to draw the net of a square pyramid, you should not mention the pasting allowances. Now quickly turn to page number 126 of your textbook. There you have to do a small activity, activity 2. We will read the activity first. Draw each shape given in the figure on a square ruled paper. Cut out each shape, fold along the edges and paste them using sellotape. What is the name of each of the solids you get? Now quickly do it with the help of your parents. What you do get? Once again, you can obtain a square pyramid. Then we can come to a conclusion that to make a square pyramid, we have more than one net. Right. Next, we will move on to the prism. I have mentioned 2 prisms in the screen. As you can see, you have used these prisms for science laboratories, isn't that so? For science experiments, you have used these glass prisms. Now today we are going to talk about the triangular prisms. Have you seen this shape before? Can you remember the kaleidoscope? that you have used to make when you were in primary classes, right? You have seen the same shape, you have used the same shape in kaleidoscope, isn't that so? So, here I have got a triangular prism for you. As you can see, there are 1, 2, 3 rectangular faces, 1, 2 triangular faces. Therefore, we can define a triangular prism as a solid object which has 3 rectangular faces and 2 triangular faces. Right. Now, shall we count the number of faces, vertices and edges of a triangular prism? Right. Let us count the number of faces. We have 1, 2, 3, 4, 5 faces, and as we have discussed before, 3 of the faces are rectangular shape and 2 of the faces are in triangular shape. Right. Next we will count the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that means altogether we have 9 edges, and as you can observe, all the edges are straight edges. Then let us count the number of vertices. 1, 2, 3, 4, 5, 6. Right, that means we have 6 vertices. So, we will go through the features once again. We have 5 faces, 2 triangular faces and 3 rectangular faces, 9 edges, all are straight edges, and 6 vertices. Right. We will then move on to the net of a triangular prism. As you can see in the screen, in the net of the triangular prism, we have 3 rectangles and 2 triangles. But when we want to make the triangular prism at school, we have to have the pasting allowances. Therefore, I have mentioned the net with the pasting allowances. But when we have asked you to draw the net of a triangular prism, you should not mention the pasting allowances. Right. Now, think about the objects, solids that you have seen in your day-to-day life in the shape of the triangular prism. Try to remember some objects with the same shape. The first thing comes to my mind is the roof of your house. Isn't that so? So, these shapes are practically there in practically you can see these shapes in your day-to-day life. Right. Now, we are going to talk about the relationship between the vertices, faces and edges in solid objects. Here, we are going to do a small activity. Right. We have come across 5 solids by now. So, we are going to list down the number of vertices, faces and edges of these 5 solids. Shall we take one by one? First, we have discussed on cube. There we have 8 vertices, 6 faces and 12 edges. Then we have discussed on cuboid. There we have 8 vertices, 6 faces and 12 edges. Then we have discussed on regular tetrahedron. There we have 4 vertices, 4 faces and 6 edges. For the grade 7 lesson, we have discussed on square pyramid. There we have 5 vertices, 5 faces and 8 edges. Finally, we have discussed on triangular prism. There we have 6 vertices, 5 faces and 9 edges. Right. Now quickly write this information in your table. List down it quickly and check whether your table is similar as mine. Right. In my 4th column, we have to add the number of vertices and faces, and we have to write the sum of it. So, I am going to compare my 4th column and the 5th column. We will see, I am going to construct a relationship between the number of vertices, faces and edges of the solids. Therefore, we will take one by one. In cube, the number of vertices is 8, number of faces is 6. So, when I add 8 and 6, the answer is 14. Then in cuboid, number of vertices is 8, number of faces is 6. Once again, the addition of the number of vertices and faces is equals to 14. Then regular tetrahedron, number of vertices is 4, number of faces is 4. Once again, the addition is equals to 8. Then square prism, number of vertices is 5, number of faces is also 5. Therefore, the addition is equals to 10. In triangular prism, number of vertices is equals to 6, number of faces is equals to 5 and the addition is 11. Now, I am going to compare the answers in column 4 with the number of edges of each and every solid. Right, we will compare. In cube, the addition of number of vertices and faces is 14 and we have 12 edges. So, the difference between the addition of the number of vertices and faces and the number of edges equals 2. Once again, we will compare the cuboid. The addition of number of vertices and faces is equals to 14 and the number of edges is 12. Once again, the difference is equals to 2. Then when we consider about the regular tetrahedron, the addition of number of vertices and faces equals 8 and the number of edges is equals 6. Once again, the difference is 2. In square prism, the addition of number of vertices and faces is 10 and when we take the difference, once again it's 2. In triangular prism also, the addition is addition of number of vertices and faces is 11. When we get the difference with the addition and the number of edges is once again 2. Therefore, in each and every solid that we have considered, the difference between the addition of number of vertices and faces and the number of edges is always 2. Right. Therefore, we can present a relationship as follows: number of vertices plus number of faces equals number of edges plus 2. So, we can name the number of vertices as V, number of faces as F, number of edges as E. Therefore, we can construct an equation as V plus F equals E plus 2. But this relationship is true only for the faces with plane surfaces. If you have curved faces, this relationship cannot be taken. Although we have observed it now, this relationship was presented by Leonhard Euler in 18th century. Therefore, we named this formula as Euler's formula. or in some cases we call it as Euler's relationship. So, once again we will say what the Euler's relationship is. Number of vertices plus number of faces equals number of edges plus 2. Right. Now, we are going to talk about composite solids. Composite solids are the solids which have made by combining two or more solids. Here, as you can see, I have presented some composite solids for you. Isn't that so? First one, we have combined two regular tetrahedrons and made a composite solid. Second one, we have combined two square pyramids and made a composite solid. Third one, we have combined a square pyramid and a cube and then made a composite solid. We will take a composite solid and discuss the features of it. Can you see the composite solid here? Okay, how many vertices are there? Count. There we have 5 vertices. And what about the faces? We have 6 faces and all are triangular faces. Then what about the edges? Quickly count the number of edges. Yes, we have 9 edges. Therefore, I am going to check whether this composite solid fulfills the Euler's relationship or not. We will see. Once again, the Euler's relationship is number of vertices plus number of faces equals number of edges plus 2. So, we will quickly put the data into this Euler's relationship and check whether it fulfills the Euler's relationship or not. Right, number of vertices is 5, number of faces is 6, number of edges is 9. So, we will add 5 plus 6 is 11, 9 plus 2 is also 11. Therefore, my left hand side is equals to the right hand side. That means I can say this composite solid fulfills the Euler's relationship. Okay, now we will quickly move on to some questions related to solids. Okay, right. Question number 1. Right. Then now you can see the composite solids also fulfills the Euler's relationship. But can you remember the rule that I have told you previously? The solids which consist of curved faces does not obey the Euler's relationship. So, you have to keep that in mind. You can use the Euler's relationship for any solid, the solids you have learnt and the composite solids, but if you have a curved face in that solid, then you should not use the Euler's relationship, because those solids does not fulfill the Euler's relationship. Now, I think we have to move on to some questions. So, shall we quickly move on to some questions? You also have to write down these questions and you have to do it with me. We will see questions related to solids. Question number 1. A solid is constructed by coinciding and pasting the square faces of two identical square pyramids. Find the number of vertices, faces and edges of the composite solid and show that it fulfills the Euler's relationship. We will once again read the question. A solid is constructed by coinciding and pasting the square faces of two identical square pyramids. Find the number of vertices, faces and edges of the composite solid and show that it fulfills the Euler's relationship. Now, here in this question, there are two parts. First, we have to find the number of vertices, faces and edges. Then we have to show that this solid fulfills the Euler's relationship. So, we will take the question part by part. Once again, they are describing about a solid, about a composite solid. That means a solid constructed by combining two solids. Here they says a solid is constructed by coinciding and pasting the square faces of two identical square pyramids. This is the square pyramid. They have taken two such square pyramids and pasted those two together, coinciding this square face. Right? Coinciding means pasting one on the other. Right? Look at this figure. I have mentioned the composite solid in this figure. They have pasted two square pyramids together and then made the composite solid. Right? Now we are going to count the number of vertices, edges and faces of this composite solid. Shall we count? I think you can count before me. Okay, number of faces. Here you can see, we will count. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 faces. All are triangular faces. Then shall we count the number of edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have got 12 edges and all are straight edges. Then let's count the number of vertices. We have 1, 2, 3, 4, 5, 6. We have got 6 vertices. Right. Now we have already got the answer for the first part of the question. We can say we have 6 vertices, 8 faces and 12 edges. Now we have to quickly move on to the second part of the question. That is, we have to check whether this solid fulfills the Euler's relationship or not. So let's check. Before checking that, we have to memorize what the Euler's relationship is. Number of vertices plus number of faces equals to number of edges plus 2. So we will substitute the values of the number of vertices, faces and edges of this composite solid, and then let's find whether it fulfills the Euler's relationship or not. We will substitute the values. Number of vertices is 6, number of faces is 8, number of edges is 12. So we will say 6 plus 8 is 14, 12 plus 2 is also 14. Now my left hand side is equals to my right hand side. Therefore, I can say this composite solid fulfills the Euler's relationship. Now, have you got the answer correctly? I think you have got it correctly. So, we will move on to another question. This is question number 2. There are 5 faces and 9 edges in a certain solid object. Find the number of vertices of the solid using the Euler's relationship. Once again, we will read out the same question. There are 5 faces and 9 edges in a certain solid object. Find the number of vertices of the solid using the Euler's relationship. In this question, they have asked us to use the Euler's relationship. That means, obviously, this solid should fulfill the Euler's relationship. As they have asked us to use, we can use the Euler's relationship. So, first of all, we will consider what the Euler's relationship is. Number of vertices plus number of faces is equals to number of edges plus 2. Right. Now, we have got the details on the number of faces and number of edges. The only thing we do not know is the number of vertices. As you have learnt in the lesson equations, if there is an equation with one unknown term, we can take all the known terms to one side and make the unknown term and take the unknown term in the other side. You can find the value of the unknown term. So, we are going to consider this as a simple equation, and now we are going to simplify that. As I have mentioned, v plus 5 equals 9 plus 2. So, first of all, we will add 9 and 2 together. 9 plus 2 is 11. Now, in my left hand side, I have v plus 5, but to make v as the subject, that means number of vertices as the subject, we have to cancel off this addition of 5 from my left hand side. Therefore, I have to subtract 5 from both sides, because if I want to cancel off a value from one side, you have to subtract that value, but as it is an equation, you have to subtract the same value from both sides. Therefore, I have subtracted 5 from both sides. So, v plus 5 minus 5 becomes v, that is number of vertices, equals 11 minus 5. Therefore, we can simply get the value of the number of vertices by subtracting 5 from 11. So, 11 minus 5 is 6. Therefore, the number of vertices in this solid can be taken as 6. I am sure that you have got the answer correctly. So, nice job. We will move on to the third question. In a certain solid object, number of vertices is 2 more than the number of faces. There are 6 identical faces in the solid. Find the number of vertices and edges separately and give a suitable name to the solid object. We read the question once again. In a certain solid object, number of vertices is 2 more than the number of faces. There are 6 identical faces in the solid. Find the number of vertices and edges separately and give a suitable name to the solid object. And this says that this solid fulfills the Euler's relationship. Okay, they are giving us more information about this solid. After providing the answer, we have to identify what this solid is. Right. Now, they says there are 6 identical faces. So, we know the number of faces, that is 6, and then they says the number of vertices is 2 more than the number of faces. Therefore, the number of vertices should be 6 plus 2, that is 8. Right. And they says this solid fulfills the Euler's relationship. Here, the only thing we do not know is the number of edges. Therefore, we know the number of vertices, we know the number of faces. The only thing we do not know is the number of edges, and they says that this solid fulfills the Euler's relationship. So, we can use the Euler's relationship to find the number of edges. So, we will do that. Here, number of vertices plus number of faces equals number of edges plus 2, that is the Euler's relationship. Here, I have substituted the values of number of vertices and faces. that is 8 plus 6 equals E plus 2. Once again, you have to consider it as a simple equation. Therefore, I need to find the number of edges. I have taken the number of edges in one side and I have taken all the other values to the other side. First of all, we will add the number of vertices and faces. Therefore, 8 plus 6 equals 14. So, we can say 14 equals E plus 2. Once again, I do not want this addition of 2 in my right hand side. So, to cancel it off, I have to subtract 2 from my right hand side. Since it is an equation, I have to subtract the same value from my left hand side also. Therefore, I have subtracted 2 from both sides. So, E plus 2 minus 2 becomes E. 14 minus 2 becomes 12. Therefore, we can get the value for E as 12. That means number of edges is equals 12 in this solid. Right. Now, we will summarize the features of this solid. Now, it has 8 vertices, 6 faces and 12 edges. Now, think quickly, what are the solids that comes to your mind? The cube and cuboid comes to your mind, isn't that so? Both the solids has the same features. But in the question they have mentioned that it has 6 identical faces. Here I have got cube and cuboid. The two solid which has the same features, but the only difference is the shape of the face. And in the question they says it has 6 identical faces. We will take cuboid first. What can you say? Does it has 6 identical faces? No. Why? It has 2 different types of faces. Therefore, we can omit that solid. The only solid we can take is cube. It has 6 identical faces, 8 vertices and 12 edges. Therefore, our answer should be a cube. Right. I think you have got that one also correctly. If you have accidentally got the answer wrong, quickly correct it in your writing book. Right. We will move on to another question. This is question number 4. Write an equality and a difference between a regular tetrahedron and a square pyramid. I will say it once again. Write an equality and a difference between a regular tetrahedron and a square pyramid. Right? Okay, we will see. Now we will compare. This is the regular tetrahedron. This is the square pyramid. Now, what is the equality that you can see in these two solids? Yes, you are correct. The regular tetrahedron has 4 triangular faces and the square pyramid also has 4 triangular faces. Therefore, we can get the equality as 4 triangular faces are there in each solid. Now, we will go for the difference. What is the difference? Okay, it has 4 triangular faces and we can consider the base of the regular tetrahedron also as a triangle. But what about the base of the square pyramid? Here, it is a square. Therefore, the regular tetrahedron has a triangular base, but the square pyramid has a square base. So, we can consider it as the difference. What is the difference? That is, the base of a square pyramid is a square. The base of a regular tetrahedron is a triangle. Right. Okay. I think you have got the answers correctly. Right. Now, before wind up the lesson, We will quickly go through the things we have learned today. First of all, we have recalled the previous memory, that means the things you have learned previously. Then we have moved on to the grade 7 lesson. There you have learned about the solid that consists of a square base and 4 identical triangular faces having a common vertex is called a square pyramid. Then you have learnt about a square pyramid consists of 8 edges, 5 faces and 5 vertices. Then you have learnt a solid with 3 rectangular faces and 2 parallel triangular faces is called a triangular prism. After that, you have learnt a triangular prism consists of 9 edges, 5 faces and 6 vertices. At last, we have discussed on the Euler's relationship. There we have you have learnt on if a solid has E number of edges, F number of faces and V number of vertices, you can denote the Euler's relationship as V plus F equals E plus 2. Now it's the time for you to do the homework. Now take out your textbooks, turn to your exercises. There you have 2 exercises in your textbook. Exercise 25.1 and exercise 25.2. So after this lesson, please do those 2 exercises and you can then be thorough with the lesson. Okay, I think the lesson is clear for you. I hope you will do the homework on time, and if you want to go through the lesson once again, or else if you have missed this lesson, you can watch the same lesson in YouTube channel NIE. Right. So that's it for today. Hope to see you soon. So take care.